Hey everyone. So today is lesson 10 in polynomial applications. Now, polynomial applications is just a fancy way of saying word problems, okay? So we're going to go through some scenarios on some applications, often real life applications that we could deal with that model polynomial functions, okay? So first guy up. A box with no lid is made by cutting 4 squares of side length x from each corner of a 10 centimeter by 20 centimeter rectangular sheet of metal. Determine an expression that represents the volume of the box. Okay, so what we're doing here is we're cutting out pieces of this metal. So we're cutting there, and we're cutting here and here, and we're cutting here and here, and we're cutting here and here. Okay, so then we're left with these flaps that can fold up. So this flap right here would fold up and become this wall of the box that has no top. Okay, so if I want an expression for the volume, volume is length times width times height. So length was 20, but look at this. I cut x away on this side and I cut x away on that side. So my new length is going to be 20 minus 2x, okay? And then same thing for the 10, it'll be 10 minus 2x for this dimension here, okay? So that's gonna give me the base area, essentially, the base length times the base width. Then I need to multiply it by the height. Well, what's the height? The height has to be x, because that ends up being the height of the flaps when I fold them up, okay? So I would have x times 20 minus 2x times 10 minus 2x, okay? So this polynomial would represent the volume. Now, sketch the graph of the function and state the restriction on the domain, okay? So again, you can use your graphing calculator to help you here. This is the beginning of the graph of the function if you were just to pop it in. Okay, so if I was just to type that in my graphing calculator, this would be what I'm looking at. Now, we gave you a very large hint here because we said state the restriction on the domain. So not everything here is going to be permissible, and we have to figure out why. If I looked at, let's just pick the 10 minus 2x portion here for a second. What I want you to see there is 5 is really the cutoff for what x can be, okay? Because if x was 5, that very last factor would be 10 minus 2 times 5, which is 10 minus 10, which is nothing. And I can't have a dimension be nothing, okay? And then anything higher than an x value of 5 is actually going to give me a negative value for one of my dimensions after that, so it's not going to work. So really, we can only look up to when x is 5. And obviously, x can't be negative, so the restrictive domain would be between 0 and 5. Okay, x would have to be between 0 and 5. So now I just changed my picture there, so that I'm just looking at a close-up of the domain that's pertinent to the context of this question. Okay, so now it says state the value of x to the nearest hundredth of a centimeter that gives the maximum volume. Okay, well, the maximum volume's right here. So we're looking for the x value there. You already have it in your graphing calculator at this point, I'm hoping. So you can calculate a max. Okay, on a Casio, you go G sub max. On a TI, you would go second trace maximum, and then you have to go left bound, just left of that hump, and then right bound, right of that hump to get it. Okay, you will get the point. The x value at that point will be 2.11. Okay, a reminder, we don't actually care what the maximum value is. We don't care, sorry, I said value. I could say volume there, what the maximum volume is, because it only said state the value of x. Okay, so if x was 2.11 centimeters, that would maximize the volume of the box in this scenario. Okay. So now it says state the maximum volume of the box to the nearest cubic centimeter. Well, you just did that on a graphing calculator, right? You've calculated the max point. So the y value at that max point was 192. Now, if you wanted to do something algebraic, you could also have taken your 2.11 and plugged it in for x, and you would have gotten 192 there. But your graphing calculator is telling me that right away. Okay, good. A toothpaste box has square ends. The length of the box is 12 centimeters greater than its width. The volume of the box is 135 centimeters. What are the dimensions of the box? So again, we have a box. We're looking at volume, so we've got length times width times height. The fact that I have square ends, I would have the same dimension there. So let's call that actually x. So that'd be x by x. And then the length of the box is 12 centimeters greater than its width. So that could be 12 plus x. Okay, so here's a drawing that we've got. And then the volume would be x times x plus 12. And we're going to set that equal to 135. Okay, once I've established my equation, I can plug that into my graphing calculator. I would like to see a sketch if you're using your graphing calculator for this stuff. So give me somewhat of a pertinent sketch, okay? I need to see numbers somewhere, like on this picture, you can see that my scale goes up to 140 on the y and negative 40 on the y min. And then you can see my x scale goes from negative 5 to 5, okay? So now visually, when I look at that, I have an idea of what x is even before I'm told the answer. So I need a context for your picture, I guess is what I'm saying. Don't just give me a random line with an intersection and not kind of point out what I'm looking at, okay? It's all that communication thing. Okay, so my x value there is 3. And so 3 is the value for x, but you have to be careful. It says, what are the dimensions of the box? So we're going to plug that back in, and we're going to say, okay, the dimensions of the box are 3 by 3 by 15. So always have some sort of a concluding statement that actually answers the question, okay? Super important that you are concluding and answering the question, okay? All right, two polynomial functions are defined as describe, so just f of x and g of x there. Describe the transformations that would need to be applied to the function f of x to obtain the function g of x. Also include specific details on how the transformations impact the intercepts. Now, when we say intercepts, we'd be talking about x-intercepts and y-intercepts. This is a great written response question for a diploma, okay? And so this is a lengthy answer. I want you to pause me for a couple of minutes, and I want you to write down everything you can think of. Okay, so here's my answer, and I want you to compare what you did with what I've done. And I want you to notice how I've laid things out for you, okay? So I'm going from an a value of 4 to an a value of negative 8. 3 went to 5, 5 went to 7, 1 went to negative 1. So let's take a look at all of this. Sorry, I said that backwards. Negative 1 went to 1. I said 1 went to negative 1. That's not what I meant. Negative 1 went to 1. So we can see that each one of these are going up by 2. So the x-intercepts for f of x occur at 3, 5, and neg 1. Notice I've labeled what those x-intercepts are. The x-intercepts for g of x occur at 5, 7, and 1. This means there's been a horizontal shift 2 units to the right. Okay, so here's the first point I want to make in a written response question. It's not enough for you to look at that and just write horizontal shift 2 units to the right. Okay, you haven't communicated how you know there's a horizontal shift 2 units to the right. So by establishing what my x-intercepts are for f of x, and by establishing what my x-intercepts are for g of x, then I have been able to establish that there's a horizontal shift 2 units right, okay? But you can't just say that without anything to back it up. Okay, then we're going to take a look at that leading coefficient. The leading coefficient on f of x is 4. The leading coefficient on g of x is negative 8. This means that a vertical reflection on the x-axis has occurred. That's what made it negative, as well as a vertical stretch by a factor of 2. That's how I would have turned a 4 into an 8. Okay? The y-intercept, because remember the question said speak about the intercepts, and so far in this question I've only spoken about the x-intercepts, okay? So now I need to conclude with the y-intercepts as well, so that I've actually done what the question asked me to do. The question asked me to speak about intercepts. I have to speak about all intercepts, okay? So the y-intercept for f of x occurs at 0, negative 180, and the y-intercept for g of x occurs at 0, negative 1400. And I just plug 0 in for x to get those. Okay, a particular polynomial function is given by p of x equals 3x cubed minus 4x squared minus 5x plus k. One factor of the polynomial function is x plus 1. Explain how to determine the value of k. Now, I know we've talked about this in class, but this word explain is super, super important. Explain means give me words, okay? You need to write like paragraph form, communicate your knowledge, okay? Then algebraically solve for k, okay? You can't just algebraically solve for k and say that that's your explanation, okay? So what sorts of things do we need to talk about? When you're doing a written response question like this, you need to approach a question like this just like you'd approach an English essay, okay? When you start doing math, you often start like right here. And the problem is, then you do work, and it looks like this. And then you run out of room. So then maybe you go up here, and you do some work up here. And then maybe you go over here because you're out of room still, and then you're erring over and you do right here, okay? And so your math work becomes like this treasure hunt of, whoa, how do I follow all of this? That's not how you would write an English essay. How do you write an English essay? Well, you start at the top and you do your stuff down here. And then when you run out of room, you head up there and you keep it going that way, okay? So you want to think that through and be nice and neat, okay? You have scrap paper on a diploma. Use it. Plan yourself out before you actually answer a written response question, okay? Super important so that you're neat. You don't want eraser marks all over your work. One of the things I notice when I mark is students inherently aren't great at erasing things. And so they'll have something erased and then they'll write right on top of it. And I'll be like, well, is that negative sign that I sort of see actually there? Are they trying to tell me it's a negative answer, or have they erased the negative? You want to make things super, super clear, okay? Okay, so because this is my explanation, because x plus 1 is a factor of p of x, we know from the remainder theorem that, that's just a remainder theorem, not reminder theorem. We know from the remainder theorem that p of negative 1 will be 0. So if x is replaced with negative 1, we can set the equation equal to 0 and solve for k. There's my explanation, okay? If this was a written response question on a diploma, this would be like a 2-point question. 1 point is coming from your explanation. 1 point is to now actually do it, okay? Okay, so here we go doing it. I've thrown in negative 1. I'm going to solve for k. I've cleaned all this up a little bit. I'm going to combine like terms and move my negative 2 over, and I find out that k is 2. All right, awesome. A gift box has dimensions as shown in the diagram below. Write an equation in factored form that represents the volume of the box as a function of x. Algebraically determine the value of x. That would produce a volume of 24 units cubed. State the corresponding dimensions of the box. Okay, so we've already done questions like this, similar. Length times width times height. So I've got 2x minus 5 times x minus 3 times 2x. Okay, and I can set that equal to 24. So here I go. There's my volume. I set it equal to 24. While I set it equal to 24, I just multiplied that 2 in. Okay, and now I can multiply these two binomials together. Okay, so now let's get everything over to one side. So I just subtracted 24 from both sides. And now I want to try and do something with this. Okay, so I factored out the 2. Now I'm left with 2 times 2x cubed minus 11x squared plus 15x minus 12. Now it says algebraically determine the value of x. So in order to algebraically figure out these x-intercepts like this, the value for x, it's set to 0. So I'm looking for an x-intercept right now. I have to factor it. In order to factor it, I have to find a factor. So remember, I'd be looking for factors of 12. So I would try +1, -1, +2, -2 until I find something that works. Okay. The first one I went with was P of 4. Okay. So I've stated that P of 4 equals 0. When I plug in 4 for x, I get out 0. That is using the remainder theorem and the factor theorem to tell me that x minus 4 is a factor. Now that I know that x minus 4 is a factor, I need to divide it out. So I head to synthetic division. I've got 4 on the outside. I have every degree represented, 3, 2, 1, nothing. So my coefficients go on the inside, drop the 2 and multiply, add, multiply, add, multiply, add. And so I end up with the next kind of factored form of this is 0 equals 2 times x minus 4 times 2x squared minus 3x plus 3. Okay? All right. (2x squared minus 3x plus 3 is not factorable. You can't tell me two numbers that multiply together to give me 6, add together to give me -3. So I'm over to the right there, heading to the quadratic formula. Okay, so 3 squared is 9. 4 times 2 times 3 is 24. So that ends up being 9 minus 24, which would give me -15. I can't take the square root of -15. So that tells me that this factor isn't going to bring me any further solutions, okay? If that factor is not going to bring me any further solutions, then the only solution for x here is coming from this factor. And if x minus 4 equals 0, then x would be 4. The only viable solution for x is 4, okay? Now, it did ask me for the dimensions. So now that I've established that x equals 4, I have to conclude the dimensions of the box are. Well, to get that, I'm just plugging in 4 to each of these original ones. So I've got 3 units, 1 unit, and 8 units. Okay? Okay. The polynomial function p of x equals x to the 4 minus 8x cubed plus 17x squared minus 4x minus 12 has a factor of x minus 2. Algebraically determine the exact values of all the zeros of the function. Okay, so I'm looking for zeros of the function, so p of x is going to be 0. I need to factor this degree 4 polynomial, but I've been given one factor, so I'm going to start with the x minus 2. I'm going to divide out the x minus 2 and see what I'm left with. So make sure every degree is represented, 4, 3, 2, 1, nothing. They're in the proper order. I can go through long division or synthetic division, it doesn't matter. I've done synthetic division on the slide. Drop the 1, multiply, add, multiply, add, multiply, add, multiply, add. Okay, and so that's going to get me down to 0 equals the x minus 2 that I just divided out. And then what's left is x cubed minus 6x squared plus 5x plus 6. Now I need to work on factoring that degree 3. So I'm still not at a degree 2. I still need to find another factor, so I'm going to test factors of the constant term, which is 6. So I could try 1, -1, 2, -2. Okay, 2 worked. So p of 2 equals 0. So now I know x minus 2 is a factor again. Okay, so now I'm going to synthetically divide this leftover piece, the x cubed minus 6x squared plus 5x plus 6. I'm going to divide that by x minus 2. Okay, so the 2 comes out. I've got 1, -6, 5, and 6. Drop the 1, add, multiply, add, multiply, add. And that's going to leave me with, so far, I've got 0 equals x minus 2 squared, because I've taken out 2 different x minus 2s, and then I'm left with x squared minus 4x minus 3. I'm down to a trinomial, degree 2. looking for two numbers that multiply together to give me -3 and add together to give me -4. They don't exist, so I'm heading to the quadratic formula. So I know some of my solutions right now, or one of my solutions right now, is x equals 2, okay, coming from this guy. But to get the solutions here, the zeros from this guy, I have to use the quadratic formula. So I've got 16 plus 12 would be 28. 28 is 4 times 7, so that'd be 2 root 7, and then everything can be divided by 2. So that'll end up being 2 plus or minus root 7 as my other zeros. So I have x equals 2 as one zero, x equals 2 plus root 7 as another 0, and x equals 2 minus root 7 as another 0. Okay. All right. If r of x is the result of translating p of x 1 unit to the left and 12 units up, then determine the equation of r of x and express it in the form r of x equals ax to the 4 plus bx cubed plus cx squared plus dx plus 3. Verify that x minus 3 is a factor of r of x. Now, this is a huge question. I want to make sure you're comfortable with this, but I also want to make sure you don't just watch me do this, okay? As in all of these notes, I am assuming you're pausing and trying things through. Partly because it's good for you to pause and try things through. Partly because you need a break from listening to me too. Okay, so I'm going 1 unit to the left and I'm going 12 units up. Well, the 12 units up is just a plus 12 on the end. The 1 unit left, well, that's going to replace x with x plus 1. Okay? So, there I go. Don't freak out. So, I replaced all my x's with x plus 1. That sends me 1 unit to the left. And then adding the 12 to the end brings me up 12. Okay, well, this is nice. I got negative 12 plus 12, so that's nothing. That's gone. Not a bad thing. Okay, now we're going to have to do a little sidebar here. We need to talk about what x plus 1 to the 4 is. We need to talk about what x plus 1 to the 3 is. And we need to talk about what x plus 1 squared is. Well, x plus 1 squared, square the first, double the product, square the last. So I got x squared plus 2x plus 1. Then if I took that and multiplied that by x plus 1 again, that would give me x plus 1 cubed. When I clean that up, that becomes x cubed plus 3x squared plus 3x plus 1. And then x plus 1 to the 4, I'm going to take x plus 1 cubed, multiply it all by an x plus 1. By the way, the very last lesson of 30-1 will teach you how to pattern look at this using something called the binomial theorem. But for now, take your answer to x plus 1 cubed, multiply everything by x plus 1, and that's going to give you x plus 1 to the 4. Okay, so we've established here x plus 1 squared is x squared plus 2x plus 1. X plus 1 cubed is x cubed plus 3x squared plus 3x plus 1. And x plus 1 to the 4 is x to the 4 plus 4x cubed plus 6x squared plus 4x plus 1. So now what I need to do is I need to take this pink line that I had left you off with. I need to replace x plus 1 to the 4 with this guy. I need to replace x plus 1 to the 3 with this guy. And I need to replace x plus 1 to the 2 with this guy. Okay, I'm going to have to shrink the font a little bit to fit all this in, but that's essentially what it looks like right here. Now I got to clean it up a bit. This -8 will get distributed into each term on this guy. The 17 will get distributed into each term on this guy. And the -4 will get distributed into those two terms. Okay, so when I get rid of all the brackets, that's what I'm looking at. And then when I combine like terms and clean it all up, my final answer would be r of x equals x to the 4 minus 4x cubed minus x squared plus 10x plus 6. Now, you will remember in the first unit, I talked about this would be an equation in terms of x. This would be a graphable equation. I could put this into my graphing calculator. I could put p of x in as y1, r of x in as y2, and what I would notice is y2 is y1, except everything's been moved 1 unit left and 12 units up. Okay. Now, perfect. We need to verify that x minus 3 is a factor. Well, how do I verify a factor? I'm going to use the remainder and factor theorem. If x minus 3 is, I mean, I could use synthetic division too, right? But it's just as easy to use the remainder theorem. If x minus 3 is a factor, I could plug in 3, and I should get out what? 0. Yeah. Okay. So let's do that. R of 3 is in fact 0. Okay. Awesome. All right. Because r of 3 equals 0, we have verified that x minus 3 is in fact a factor of r of x. Okay, I'm going to show you another way to do that same question. Alternatively, we could have done the replacements to the factored form we had solved for in the first part. I've shown you this next for your reference, but you take a gamble using it because if it was wrong, if that original factored form is wrong, you're automatically wrong for the next section. But just to show you, okay, we had left off with this factored form, this x minus 2 squared times x squared minus 4x minus 3. So now what we're going to do is we're going to replace my x with x plus 1, and we're going to add 12 to the end. Just like I did with the original form, the original general form, I'm just using the factored form instead, okay? All right, so I end up with x plus 1 minus 2, so that's where the x minus 1 comes from. Here, I have to square that, so that's x squared plus 2x plus 1. Distribute the negative 4. I need to clean all this up a little bit. So that gives me the x squared minus 2x minus 6. But now, like really, I don't know if this is any easier than the last example I gave you, because now x squared has to be multiplied by everything there. Negative 2x has to be multiplied by everything there. 1 has to be multiplied by everything there. Okay? And then that gives me x to the 4 minus 2x cubed minus 6x squared minus 2x cubed plus 4x squared plus 12x plus x squared minus 2x minus 6 plus 12. Combine like terms, I end up with the same r of x. Okay? But again, the gamble that you're taking is you're using the factored form that you had figured out. If you had factored this wrong and you do the right replacements, you kind of just shot yourself in the foot because you didn't have to use that factored form, okay? So whenever possible in math, you don't want to use something you've solved for in the next step. If there's an original that you can use instead, you should always go for that original, okay? All right, awesome. The dimensions of a rectangular prism are 10 centimeters by 10 centimeters by 5 centimeters. When each dimension is increased by the same length, the new volume is 1008 centimeters cubed. What are the dimensions of the new prism? Well, we're going to increase each of these dimensions by the same length. So let's call that length x. That's going to now give us 10 plus x, 10 plus x, and 5 plus x. We know that the volume of a box will be length times width times height. So we'll go 10 plus x times 10 plus x times 5 plus x equals 1008. At this point, I'm going to put this right into my graphing calculator. We are not told we had to algebraically do this. So our graphing calculator is totally fine, but you have to provide a picture. If you're using your graphing calculator, I need to see a proper picture with a proper context. I need to see a window setting. I need to see some points, something so that I know where you are in the general scheme of the coordinate system, okay? So here's the picture I've shown you. I've clearly shown you that I'm going from negative 100 to just a little over 1,000 there, probably 1,100 on my y max, or my y scale is negative 100 to 1100. My x scale is negative 10 to 10. And then I see this intersection point here. So I calculate the intersection point and I get x is 2. Now, the answer is not how much am I increasing the dimensions. The answer is what are the new dimensions of the prism. So I have to take the knowledge that x is 2 and figure out what the new dimensions are. So my answer answers the question. Always make sure your answer answers the question. So the new dimensions are 12 centimeters by 12 centimeters by 7 centimeters. Okay. Awesome. All right. You guys are getting to be pros at this. The volume of a box is represented by the function v of x equals x cubed plus 6x squared plus 11x plus 6. The height of the box is x plus 2. If the area of the base is 24 centimeters squared, determine the height of the box. Okay, so I know the height of the box is x plus 2. If I know the height of the box is x plus 2, then that's actually a factor that I could divide out of v of x. If I divided that out of v of x, I would actually be left with the area, right? If volume is, let me write this down for you here. If volume is length times width times height, and I divided both of those by height, I'd be left with length times width, which is the area, okay? So I've got the volume as x cubed plus 6x squared plus 11x plus 6. I know the area of the base is 24, and I'm going to multiply that by the height, okay? Because it's the area times the height. So I'll divide both sides by the height. Okay, so either I'm going to use synthetic division or I'm going to use long division here. I chose synthetic. Give you a sec to do that. So you should end up with x squared plus 4x plus 3. So we end up with x squared plus 4x plus 3 now equals that base area, knowing that the base area is 24. So now I got a cute little quadratic here to solve. Bring my 24 over and factor. Two numbers that multiply together to give me negative 21. Add together to give me 4 would be negative 7 and 3. Okay, and then we got to think about the context of the question. Negative 7 doesn't fit, but 3 would. Okay, so it says determine the height of the box. The height of the box is 5 centimeters, because remember, the height of the box was x plus 2. X equals 3 is not the answer, it's the value for x. The height of the box is the answer. Always ask yourself, have I answered the question? Super, super important. All right, alas, my time is up and your fun begins. So this is what you're doing for homework. And then if you have any questions, please reach out and make sure you're coming and seeing me with all the questions that you have. I want you to feel super, super comfortable about this, okay? Next up, the next lesson that we do, we'll start in on function operations, okay? So until then, we'll see each other soon. Take care.